You know, a real storm is brewing in the world of AI. But here's the thing. It's not coming from the usual critics on the outside. Nope. It's coming from the very people who built the whole thing. This is a story about a deep, fundamental problem, and it all starts with a really stark warning from the man they call the Godfather of AI, Geoffrey Hinton.
Now let that sink in for a second. This isn't some skeptic yelling from the sidelines. This is the architect of deep learning, the guy behind the entire revolution. And he's sounding the alarm about the very systems he helped bring to life. I mean, that's an incredible act of conscience, and it forces all of us to ask a really serious question. What did he see that made him this concerned? So, what is it that's keeping the Godfather of AI up at night? Well, it's not just about a few bugs or glitches in the system. He sees three fundamental, dangerous threats that are baked right into the DNA of modern artificial intelligence. Okay, Hinton's warning pretty much boils down to these three bombshells. First, opacity. These AIs are total black boxes. We have literally no idea how they make their decisions, which means we can't ever really control them. Second, they're just plain unreliable. They will confidently make things up, what we now call hallucinating, because they don't have any real concept of what's true. And third, and this is a big one, the whole economic model is a disaster. It's designed to suck up our collective knowledge, funnel all that wealth to a tiny group at the top, and then what, offer us a handout in return? And here's the kicker. These issues, the black boxes, the hallucinations, the inequality, they're not just accidents. They're not just the result of bad programming. Hinton and a growing number of others are arguing that these problems are the inevitable result of a massive, fundamental flaw in the architecture of AI itself, a flaw they're calling the approximation trap. Right at its mathematical core, every single large language model today is built to do one thing: guess. You see that little squiggly equal sign? That means approximately. The system is designed from the ground up to find statistically probable answers, not deterministically true ones. It's a system built on correlation, not on comprehension. It is always, always guessing. And this slide just illustrates perfectly why it has to guess. See, all that knowledge gets compressed into something called dense embeddings. The best analogy is this. Imagine taking 1,000 different, beautiful, distinct colors of paint, each one a clear, separate concept, and then you just mix them all together into one big bucket. What do you get? You get a dense, murky brown mud. Now you can look at that mud and guess, there's probably some red in there, maybe some blue, but you can never, ever get those original pure colors back. They're gone, lost forever in the mix. That's what causes AI hallucinations, all those concepts just bleeding into each other inside that computational bucket of mud. This choice of architecture has huge consequences. Current models use a trick called attention to figure out what's important in a conversation. But the more context you give it, the harder and harder it has to work. The computational cost just explodes exponentially. It's like trying to find one specific grain of sand on a beach that just keeps getting bigger and bigger. So what's the alternative? Well, it's a system that knows exactly where to look every single time. It's fast, it's precise, and it's transparent, no matter how much data you throw at it. So if the very foundation of AI is cracked, what's the alternative? The answer might just be a completely new foundation, something called the semiotic web, which promises a radical, fundamental shift away from this probabilistic guessing and towards genuine, verifiable knowing. The absolute core building block of this new system is the token. And please, whatever you do, do not confuse it with a regular AI token. A token is just a meaningless, statistical fragment of a word. A token, on the other hand, is a semantic atom. It's a verified concept, kind of like an entry in a universal dictionary. And it has its own unique, unforgeable cryptographic ID and a complete, traceable history of where it came from and who verified it. It's a whole different ballgame. This new system is built on 3 layers. Think of it like this. At the very bottom, you've got this universal, decentralized library of all verified knowledge. Then in the middle, you have specialized layers of knowledge curated by experts, doctors, engineers, you name it. And then right at the top, you have your own personal AI twin that runs on your device, understanding your unique context while guaranteeing your privacy. And the results of building this way, they are absolutely staggering. By just replacing that fuzzy guesswork with direct lookups of these verified tokens, this new system is up to 20,000 times faster. I mean, that's the difference between waiting minutes for a complex answer and getting it, poof, in a fraction of a second. And this isn't just about speed, it's about radical efficiency. This architecture could lead to a 96% reduction in the cost of both training and running AI systems. And that is a huge deal. especially when you think about the massive and frankly growing energy footprint of all the current models out there.
And this, right here, this brings us to the holy grail of computing, a constant time O of 1 lookup. It's like having a magical librarian who can find any book in the entire Library of Congress in the exact same amount of time, every single time. It doesn't matter if you're looking for one piece of information or a million. The system just doesn't slow down as it gets smarter. Incredible.
But look, a brilliant technical solution is only half the battle, right? The real question is, how does this new architecture directly address Geoffrey Hinton's deeper fears about jobs, about the concentration of wealth, and, well, about human dignity? The semiotic web proposes a fundamentally different economic model. Today's AI is extractive. Its main asset is hoarded data, and its goal is basically to replace human labor and funnel all that wealth to the top. This proposed new model is participatory. The core asset becomes verifiable comprehension, and the role for us humans shifts from just being a data source to be replaced to a knowledge curator who is directly compensated for their expertise.
And this isn't just some fantasy. It's built right into the system's design, with two key features. First, there's a marketplace that automatically pays you with micropayments every single time someone uses the knowledge that you've contributed. Second, there's a built-in AI tax that takes a tiny slice of those massive efficiency gains to fund things like retraining programs and to support people who are displaced by automation. It's a system designed to actually reward contribution, not just hand out charity.
But this new foundation doesn't exist in a vacuum, right? It also has to connect with other big ideas about the future of AI, especially those from another pioneer in the field, Yann LeCun. Now, what's really cool is that these two powerful visions, they're not at odds with each other at all. They're basically two sides of the same coin. See, Yann LeCun argues that true intelligence has to be grounded in physical reality, learning how the world works through observation. The semiotic web argues that intelligence must first be grounded in verifiable meaning, knowing what things are. You put them together and you have the potential for a truly intelligent AI that understands both meaning and reality with complete transparency.
And that brings us to the fundamental choice that's facing the entire field. Geoffrey Hinton's warning has made the stakes crystal clear. Do we keep going down this path of just refining statistical approximation, getting better and better at guessing inside an opaque, inefficient, and frankly extractive system? Or do we pivot to a new foundation, one built on verifiable, transparent, and genuine comprehension? The architecture to actually do it might already be here. The only question left is whether we'll choose to build it.